This is my 5th video for the limits problems, revision on limits pure maths. As I shown earlier videos of 41 questions, you'll see from their remaining problems. See question 42, I have shown already 4 videos for limits and nearly 40 questions. Next problem, limit x approach to 0, sine pi cos square x over x square. Find the limit value of this when x approach to 0. Important question. What happens if we substitute x for 0? Cos naught is 1. 1 times pi pi. Sine pi naught over naught. Therefore, this is one of the meaningless pattern. Therefore, you have to show some different simplification form to get the answer. See how the answer is limit x approach to 0. Can write this part sine this sine 180 minus theta, sine theta, sine 180 minus theta, second quadrant, sine theta. This pattern sine pi minus pi cos square x. Is it okay? Basic trigonometry identity is sine pi minus theta, pi minus angle, sine angle over x square. Or otherwise, what? Take the pi out, limit x tends to 0, limit x approach to 0, sine, if I take the pi out, 1 minus cos square, 1 minus cos square x over x square. Okay, the sine take out, sine pi into 1 minus cos square over x square. Now we have general form sine theta over theta, sine theta over theta pattern. So limit x approach to 0. Can I show this sine theta? Here theta this. This is act as sine theta, then over theta without the sine. Pi into 1 minus cos square x, and there is the x square below, right? Now see if everything is okay. Sine available, pi there, 1 minus cos square okay, this is x square okay. This is an additional term not available in the original given question. You have to remove this, the division, then we multiple. Pi into 1 minus cos square x. Okay, important question. These are near term papers, final exams. This is for revision. Those who take this year exam and next year exam, they can view these videos because of 25 marks structure type. Grade 12 is limit lesson into differentiation calculus part. Okay, now what happens? See, if you put x for 0 below, cos naught is 1, 1 minus 1, 0, therefore total is 0. So this is theory applicable, sine theta over theta pattern. Sine theta over theta form, this answer is 1 into pi over x square, or sine square. Here this is okay, here pi. This also we can change into another sine trigonometric limits. 1 minus cos square is sine square over x square. That also 1, okay. That also 1, sine 1 minus cos square sine square over sine theta over theta or square of that also 1. Therefore the answer is pi, is it? Answer is 1 into pi into 1. You can write this also in the Let's try another step. 1 minus cos square, say sine square over x square. Otherwise sin x over x, all things square. Answer is 1. Completely final solution, pi. So limit exists. The answer equal to pi. Okay, next question 43. My target to work nearly 70 problems, maybe in one video or 2 videos. I will complete those preparing for exams. Very important problems I am showing. You can improve your limits knowledge through these revision videos. Next question 43. Limit x approach to pi by 2 2 minus sin x minus sin square x over 1 minus sin x. Trigonometric limit. What the answer when x approach to 90 degrees or pi by 2? Always first just directly substitute and see what happens. If it's 90, sin 90 is 1, sin 90 is 1, 1 minus 1, 0. Here 1, 1, so 2 minus 2, 0. Therefore, one of the meaningless form, 0 over 0 pattern. Therefore, rearrange into any other form to simplify. But you can factorize. The numerator can be using some O-level knowledge, that quadratic factorization. Check what are the factors about the numerator. If you factorize 2 bracket form, is it 1 minus sin x into what? Check 2 there, 2. Is it plus sin x? Okay, is it check value 1 times 2 plus sin minus 2 sin minus 1 sin. Yeah, minus sin square. Therefore, now it becomes a simple question, right? So 1 minus sine, 1 minus sine cancel. So remaining, apply the sine 90 here. 2 plus sine 90 is 1. Therefore, the answer is 3. So if you want to work many hard long questions, short problem, then only is familiar with the idea of approaching limit. So question 44, next problem 44, limit x approach to 0, 2 sin x minus sin 2x over x cube. Another trigonometric part. Think how that. If you directly put x for 0, sin naught, and below also naught, so meaningless form, right? One of the indeterminate form. Therefore, use of any other mode, we have to calculate the answer. So how that? You know, double angle formula, sin 2x is 2 sin x cos x. So take and out, simplify something. So limit x approach to 0, 2 sin x, sin 2x is 2 sin x cos x, 2 sin x cos x over x cube. Okay, over x cube. Next, take the common factor, take the 2 sin x out and see what happened. 2 sin x take out. Limit, right here, limit x approach to 0, take the 2 sin x out, 2 sin x take out, then what is that, 1 minus cos x over x cube. In trigonometry we have sin theta over theta is 1. So connect to that part and simplify. Now you know familiar part, we work many double angle method. What is cos 2 theta? What is cos 2 theta 1 minus 2 sine square theta. Therefore 1 minus cos x. But 1 minus cos x, 2 sine square x by 2. So you can change to sine and will be an answer for that. So here limit x approach to 0, 2 sine x, what is 1 minus cos x, 1 minus cos x, 2 sine square x by 2 over x cube, right? Now rearrange into sine theta over theta form. Here sine x, then below x. Here sine x by 2, therefore below x by 2. So that is limit x approach to 0. First I complete sine x, then below x, that's the trigonometric theorem, limit theorem, sine x over x. But the other one, sine x by 2, then below x by 2, okay? But here square is not completely square. Completely square. Now check any other accuracy, any additional terms here available. Sine x, okay. Sine square x by 2 is okay. Here see x square into x, x cube also okay. And here 2 into 2, 4. But here no 4. The 4 available down. See here denominator 4 is down. This 2 square 4 can take up numerator, that's that 4. So everything okay, no any additional term, right? Then write the answer. Therefore, sine x over x when x tends to 0, 1. Sine x by 2 over x by 2. When x tends to 0, x by 2 also 0. Therefore 1. So the easy answer is 1. Unity solution is 1. Next question 45. Problem 45. Limit x tends to pi by 6. X tends to pi by 6. 4 cos square x minus 2 over 1 minus 2 sine x. 1 minus 2 sine x. Find the answer when x tends to 30 degrees, or we call pi by 6. So think a model how to work this question. So straightly if you apply x4 pi by 6, what is cos 30 root 3 by 2? So square is 3 over 4. Okay, cos 30 root 3 by 2. So 3 over 4, 4 cancel. Here sine 30 half 2 cancel. 0, okay, 4 cos square x minus 3. Minus 3, right? 3. Here minus 3. Then only 0 over 0 problem. Okay, therefore we use any other method. You change to sine, you write the cos square theta 1 minus sine square theta form. Change the cos square x 1 minus sine square x. And here 1 minus 2 sine available. Sine is okay. For specially limit problem, we have the syllabus. Very first video I shown. There's no e to the power question, the final papers, no logarithm problem. Directly, right? So here, limit x tends to pi by 6. For what is cos square x? 1 minus sine square x. 1 minus sine square x. And outside 3 over 1 minus 2 sine x. So stop the video, you complete it, pause the video, try your own and later check with my solution. So how if I multiply the 4 and simplify limit x approach to pi by 6, 4 minus 3, 1 minus, is it okay? 4 minus that, minus 4 sine square x. Okay, 4 minus 3, 1 minus 4. Below 1 minus 2 sine x. So if you identify properly what happened here, you can factorize. A square minus b square factorization. A minus b, a plus b, right? So factorize limit x approach to pi by 6. Here factorize 1 minus 2 sine x, 1 plus 2 sine x. 1 minus 2 sine x into 1 plus 2 sine x. Okay, that check value over 1 minus 2 sine x. So it's cancelled. Then you can apply direct substitute for x for pi by 6. 1 plus 2 into sine 30 half. So 2 cancel, answer is 2. 1 plus 2, answer is 2. 1 plus 1, answer is 2. Next question number 46. Problem 46. There is limit x approach to pi by 3 tan square x minus 1 plus root 3 into tan x plus root 3 sin x minus root 3 cos x. Okay, the important question. So if you directly substitute tan 60 root 3, tan 60 is root 3. So here 3, here root 3, root 3, root 3, 3 in 4 here, here root 3, see 0, here 3, here root 3, 3, 3, 0. Here sine 60 root 3 by 2, cos 60 half root 3 by 2, 0. So one of the meaningless pattern, right? Then decide the method. So I publish some other videos also, some other language medium, Sinhala and Tamil medium too. So English medium, the title become in English. Then you watch those English medium students. The title becomes English, you watch that video. Title is Sinhala, that's I publish for Sinhala medium students. So my students ask me to prepare to show publish videos in Sinhala medium, Tamil medium, because I am familiar with all three languages. The school too, I am doing classes in that both media, English and the other Tamil medium too. Sinhala also can be. So therefore, the students who will in English medium only, you see the title in English and view that video. Okay, series. So if you're very clear in the quadratic equation pattern, if the alpha and beta two roots, write the equation, that quadratic how it's you learn in our theory class. X square minus sum of the roots, is it? Sum of the roots plus what? Product of the root, alpha, beta, equal to 0. If a roots are given alpha, beta, this is the way how we show the quadratic equation. See, this is something like that. Sum of the root, multiple of these two root, therefore it can be factorized. Here, what are the roots? 1 comma root 3, alpha comma beta, like that. Root 3 and 1 are the factors. So you can, if you have a good idea about that, by viewing this problem, by observing this, quickly you can write that factorized pattern. Therefore, limit x tends to pi by 3. So you can factorize this. Tan x minus root 3, x minus alpha into x plus alpha, tan x plus 1. Check. If you multiple, that becomes the answer. It's a simple way. If you check, that's the answer. No, that's the answer. Okay. So mostly if you show in like this bracket pattern, there's a term comes below, can be cut that. See, all the 40, nearly 45 questions we worked, most question factorization pattern or two bracket pattern. Below numerator can be cut by that. Therefore, one of these below. Try to change. Take the cos out, take the cos x out, take the cos x out, take the cos x out here, then minus root 3. Here no cos. What happened if you took the cos out? Just divide by cos. What is sine divide by cos? Tan x. Okay. If your problem, multiple the cos and see. Tan means sine over cos. If you multiple cos cancel sine x, root 3 cos x. So, okay. Therefore, this cancel. It becomes a simple question now. Look like a long part, but simple problem. Now put x for pi by 3. Put x for pi by 3. Tan pi by 3 root 3 plus 1 cos pi by 3 half. Therefore, the answer what? Is it okay? No, I miss here minus, check that because minus into minus plus root 3, minus 1, x minus, I told that, x minus alpha into x minus beta. See that? Therefore, your root 3 minus 1. So the final answer, take the 2 up. 2 into root 3 minus 1. Is the limit axis problem can be using factorization. Can go to the answer. Next question 47. Problem 47. Tan square x minus 3 tan x minus 3 tan x plus 2 over sin x minus cos x. Same idea. Sin x minus cos x. Here limit approach. Limit x approach to pi by 4. X approach to pi by 4. Similar type. Check how that. If you straightly apply pi by 4, tan pi by 4 is 1. 3 1 minus 3 plus 2, that is 0. You know, sin pi by 4, cos pi by 4, both same answer. Therefore, below also 0. 0 over 0, meaningless pattern. So, we use some different pattern. So, can you factorize the numerator? See, O-level quadratic factorization. You can factorize that numerator. Limit x tends to pi by 4. How the factors, try to factorize that. Tan x minus 2 tan x what? Yeah, plus 2, therefore minus 1. Check value. Multiple tan square, okay. Minus tan, minus 2 tan, minus 3 tan, okay. Everything okay. Over, as I mentioned earlier problem, one of these terms should come down, then only cancel the remaining answer, right? There was sine cos, no chance to write this, but if you simplify further, you can take the cos out, Then what happened? Here no cos, so if you take out, it becomes sine over cos, that is tan x minus 1. So very straight. So here cancel. Now apply the values for remaining. Tan pi by 4 1 minus 2 cos pi by 4 1 over root 2. So here minus root 2 is the answer. Minus root 2 is the answer. So like a simple question, look like simple, but is that problem 25 marks in your exam paper, structure, pure maths, final papers, one problem. Also those are juniors, you have a couple of questions in your first term, second term, school exam papers. We're giving couple of, not only one, maybe 3-4 questions come this for the very first learners or the juniors. Okay, next question 48. Problem 48. Limit x approach to pi by 4 cos 2x over cos cube x minus sin cube x. Cos cube minus sin cube. See a method when x is 45 degrees, pi by 4. So if you apply pi by 4, 90, cos 90, 0. Cos and sin, same solution for pi by 4, 1 over root 2. 0 over 0, therefore one of the meaningless pattern, right? Therefore target to solve different method. So if you are very familiar with trigonometry, trigonometry is the heart of the mathematics. Without trigonometry, no mathematics combines it. Applied or pure, every part trigonometry. According to my knowledge, statistics and probability only, no trigonometry, no word called sine or cos. Every lesson we use this trigonometry. Therefore, very important. Learn properly the hard work in trigonometry. Then actually must become easier. Okay, if you're very familiar with the trigonometry, what is cos 2x? First principal expansion. First time we are learning cos 2 theta is what? Cos square theta minus sin square theta. Later only we say cos 2x, 2 cos square minus 1 or 1 minus 2 sin square x. Very formal one, that means the principal value is cos square x minus sin square x. Also this can be factorized. A cube minus b cube pattern will start. So limit x approach to pi by 4 cos 2x cos square x minus sin square x over below a cube minus b cube pattern. What are the factors? A minus b, one factor. Cos x minus sin x. Other one what? A square cos square. If it's minus here plus sin x cos x plus cos square x. Okay, you can do this. Okay, cos square x. So therefore limit x approach to pi by 4. You know, cos square minus sin square, factorize a minus b, a plus b form cos x minus sin x, cos x plus sin x. Okay, therefore cos x minus sin x cancel. So cos x plus sin x numerator, balance part in the numerator. Okay, next what? The other bracket, cos square plus sin square 1 plus sin x cos x, right? Plus sin x cos x. Now it's okay. There's no minus, therefore no doubt it become an integer value. That means a value. So put x for pi by 4. Cos pi by 4 1 over root 2 plus sin pi by 4 1 over root 2 over 1 plus 1 over root 2 multiple 1 over root 2. So simplify and get the answer of this solution. What is that? 1 over root 2, 1 over 2 over root 2, 2 over root 2 over 1 plus half. Is it half? Okay. So here 2 over root 2 or divide by 3 over 2. So it goes up, then therefore answer 4 over 3 root 2. Otherwise multiple by root 2 and cut the 2 also root 2. Okay, if you want to irrationalize your primary OL maths, irrationalize the denominator, catch that answer. Next question 49. Problem 49. 4 cos square x minus 1 over sin x minus sin 2x. Here the value is x tends to pi by 3. Limit x approach to pi by 3. See how that x approach to pi by 3. So always you directly substitute and check. Sometimes it become direct substitute become a unit answer. That means determinate answer. Then it's correct. Therefore check what happened. Cos 60 degrees is half. So numerator 4 into 104. 1 minus 1 0. Below this is sine. Is okay, sine pi by 3, 60 root 3 by 2. Here 2 pi by 3, same answer, therefore 0. No? Sine 120, sine second quadrant as well as the first quadrant value. Therefore 0 over 0 cannot be find the unique answer, one of the meaningless pattern. So we use any other form. So limit x approach to pi by 3. Now can I factorize a square minus b square pattern? Factorize a minus b, 2 cos x minus 1. The other factor 2 cos x plus 1. Okay. Over. Here you write the sine 2x is 2 sin x cos x. Sine 2x is 2 sin x cos x. So sin x minus 2 sin x cos x. Okay. Therefore limit x approach to pi by 3. 2 cos x minus 1, 2 cos x plus 1. Below take the sine common factor, take the sine out, sin x take out. It becomes 1 minus 2 sin x, 2 cos x. Then we cancel. Negatively cancel, minus, with the minus sign cancel. So minus, next you apply the answer. Cos 60 half. Half into 2 is 1. 1, 1, 2. Sin 60 root 3 by 2. So the answer was that minus 4 over root 3, right? Minus 4 over root 3 is the answer. Next question number 50. That is limit x approach to pi by 4. X approach to pi by 4. 1 minus tan cube x. 1 minus tan cube x over cos 2x. So think a method. Stop the video and try on. You try whatever you have to practice, then only it's become easier. Copyright is worst. Data wastage only if you copyright. So these days you can, with the online learning, stop the video, but Zoom or Google cases you can't. Google Classrooms or the Zoom platforms you can't. You stop the video and you can't try it. That's the advantage of YouTube channel. I choose this. So how that? Can I factorize 1 minus tan cube if I factorization? A cube minus b cube pattern. If I factorize 1 minus a minus b. Okay, the other one, a square plus ab plus b square. Okay, plus b square. So after showing this factorization step, you would think how the cos 2x. That's why I said trigonometry very important. Cos 2x also one of the solution or conversion to tan, double angle. What is cos 2 theta? 1 minus tan square theta over 1 plus tan square theta. So write that 1 minus tan square x over 1 plus tan square x. That's not limit, that's trigonometry. So hereafter, limit x approach to pi by 4, or you can factorize 1 minus tan x, 1 plus tan x. So 1 minus tan x cancel. So another 1 plus tan x available. Also this denominator goes up, right? Therefore 1 plus tan square x into 1 plus tan x plus tan square x over what? What happened below? Here 1 minus tan cancel if you factorize. 1 minus tan, 1 plus tan. 1 minus tan cancel, 1 plus tan remaining. 1 plus tan is remaining. Now no problem, all are positive. So apply the answer. Tan pi by 4 is 1. 1, 1, 2. 1, 1, 1, 3. 1 plus 1, 2. The answer is 3. So there's a unique solution. Direct. If you direct substitute, meaningless form. By using any other mode, there's an answer. Next question 51. My target to work nearly 70 problem, all the model paper questions and few past exams also will show. Limit x tends to 0. Limit x approach to 0. 1 minus sine 2x minus cos 2x over 1 plus sine 2x minus cos 2x. The last model paper, my pure mathematics model paper number 6, I answered superb question one limit. You can refer that in the video number 2, second video. I think there is second video. You can see that question. Discussion of pure model paper number 6, second video, super problem available. Those are new. We have a lot of questions. This mathematics like a C, you can't limit it, no limit. This indeterminate mathematics a lot because many problems available, every chapters, every lessons like that. Okay, see this how to work. So double x tends to 0, x approach to 0. So we can change to double angle method. Always such a question, try to remove this 1. Try to remove that 1. If a minus 1 only, that 1 can be removed out. 1 minus 1. Therefore cos 2x, change the cos 2x into sine. 1 minus 2 sine square x. Okay. Then only this 1 cancel. So limit x tends to 0, 1 minus sine 2x, what is cos 2x? 1 minus 2 sine square x over the same method, write the cos 2x, 1 cos 2x minus 2 sine square x. Then see the number 1 is cancel, 1 cancel. Then what happened, the remaining part, limit x approach to 0, 1 cancel, minus sine 2x plus 2 sine square x over, because the 1 cancel, sine 2x minus plus 2 sine square x. Now again you can take the sine out after converting sine to theta. 2 sine theta cos theta. Okay, sine 2x is 2 sine x cos x form. Write the sine 2x is 2 sine x cos x and take the sine part out. So limit x approach to 0. Can I take the sine? I write the positive first. You can take the 2 also out. Sine 2x, 2 sine x cos x. Here also 2. Take the 2 sine x out. 2 out, sine square, 1 sine out. Another sine remaining. What is sine 2x? 2 sine x cos x. Sine x out, therefore cos x. Okay, that. And see below what happened. The same method, take the 2 sine x out. 2 sine x take out. It becomes sine x plus cos x, right? Plus cos x. So you cancel. Remaining, write the solution. X for 0. Sine naught naught, cos naught 1, sine naught naught, cos naught 1. Therefore, it has a limit exists. The answer is minus 1. Very important, not the plus 1, minus 1. See next question 52. Problem 52. Limit x approach to 1. X plus x square plus x to the power 3 and plus x to the power n, x to the power n and minus n, okay, over below x minus 1. This is the question. Find the limit answer when x approach to 1. When x tends to 1, what is the answer? See what happened directly if we apply x for 1. Here how many x there? X power 1, x power 2, x power 3, x power 4. N times such x available, right? If you put x for 1, 1 plus 1 plus 1 plus 1 plus 1 plus up to n times. 1 plus 1, 2. 1 plus 1 plus 1 is 3. 5 times 5. 1 n times. Answer is n. Minus n 0. Below also 0. Therefore that is a meaningless pattern. So use some method of simplification to get the unique solution. See that method. Limit. It's algebraic limit, not a trigonometry. X plus x square plus x cube and so on, x to the power n. See the minus n, can I write? That's the tricky of this question. The minus n, there's a 5. For example, think the 5 available. I can show the 5 how? 1 plus 1 plus 1 plus 1 plus 1, 5 times. Like that. N, can I write that? 1 plus 1 plus 1 plus like that n times, right? N times over x minus 1, right? Now we pair it. Now we rearrange to our limit theory. What the algebraic limit theory? X to the power n minus a to the power n over x minus a. See if I take the first one. Minus 1. Okay, take the second x square minus 1. Can I write the 1 also 1 square? Okay, plus next one x cube minus 1. Say 1 cube. Like you can continue up to what? X to the power n minus 1. That one you say 1 to the power n. Is it okay? Nice question. Nice work. We know the idea only can get the answer such method. Now we write separately. Divide, use the limit theorem separately. Limit x approach to 1, x minus 1 over x minus 1 plus limit x approach to 1, x approach to 1, x square minus 1 square over x minus 1. Okay, next one, plus limit x approach to 1, x cube minus 1 cube over x minus 1. Okay, right, next class, x to the power n minus 1 to the power n over x minus 1. You also limit x tends to 1, right? Now you have the answer for every part algebraic limit n a to the power n minus 1. So here is okay, no problem, is 1. There is 1, we can write that pattern. 1 plus, here write the limit theorem, x to the power n minus a to the power n over x minus a. The answer n a to the power n minus 1. Next one, plus same method, n a to the power n minus 1. How the next one become 4, 1, 2 square. At last what the answer? N into 1 to the power n minus 1. You know 1 to the power anything is 1. Therefore here 1 plus 2 plus 3 plus up to n is the final answer. What is this? Sum of first n natural numbers. 1 plus 2 plus 3 plus 4. Sum of first n natural number. What is the formula? N by 2 n plus 1. Therefore it has a limit answer n by 2 n plus 1. Is the solution. Very one important question. If you practice this, sure you can answer the final paper. No doubt, no problem than this. If you revise this many times and practice the ideas, factorization, trigonometric patterns. Okay, next time I'll show some more problem. I target nearly 70 problem to work. In the 1 or 2 videos, I'll finish this complete revision on limits.